Ever feel like you're just drowning in information? Well, today we're grabbing our detective hats because we're going to crack the case of how to turn all that confusing noise into crystal clear, useful numbers. Let's dive in. I mean, just think about it. We are absolutely swimming in a sea of data every single day. You've got the big stuff, like clinical trial results and economic reports, and then you've got the personal stuff, like how many hours you spent looking at your phone yesterday. On its own, it's just this chaotic jumble of numbers. So the big question is, how do we even begin to make sense of it all? Well, what if I told you there's a toolkit for exactly that? A set of really powerful instruments that lets you step into all that chaos, find the hidden clues, and actually piece together a coherent story. And listen, this isn't about boring math class stuff. This is all about discovery. So what is this amazing toolkit called? It's called Descriptive Statistics. Think of this as your entry-level, all-purpose detective kit for any data investigation. So what does that actually mean? Well, descriptive statistics are basically the fundamental methods we use to bring order to chaos. They let us take these huge mountains of data, summarize them into just a few key numbers, and then present what we found in a way that's, actually meaningful to someone. To stick with our detective theme here, you can think of these tools as your magnifying glass and your fingerprint kit. Now, they're not going to solve the whole mystery on their own, but they are absolutely essential for finding those first, crucial clues that are buried deep down in the data. All right, so what's the first tool we pull out of our kit? We're going to start by looking for the typical value in our data. And for that, we use something called measures of central tendency. In any good story, you need a main character, right? In data analysis, that main character is what we call the typical or the central value. It's the one number that best represents the heart of our dataset. It's kind of like our first person of interest in the case. Now, to find this main character, we have three primary tools. First up is the mean. That's your classic average you learned about in school. Then you've got the median, which is the exact middle value once you've put all your data in order. And finally, the mode, which is just the value that shows up most often. The real key here is knowing which tool to use and when. But, a good detective knows there are always potential twists. In data, our main villain is the outlier. It's a single, extreme value that just doesn't fit in with the rest, and it can completely throw off our investigation if we're not careful. Let's look at our really simple lineup of suspects or data points. We've got 2, 3, 4, 5, and then 100. It's pretty obvious who the outlier is here, right? That 100 is just way out there compared to the others. And here's where we see the problem. If we use the mean, that one outlier, that 100, drags the average all the way up to 22.8. But if we use the median, the middle number, we get 4. I mean, look at that difference. Which one of those feels more typical of our data? It's 4, right? The median wasn't fooled by the outlier. It gave us a much, much truer picture. So the big takeaway is this. When your data is skewed, which just means it's being pulled in one direction by those pesky outliers, the median is going to be your most reliable tool. It's robust, it's steady, and it won't be easily fooled. Okay, so we've found our central character. Awesome. But that's only half the story. Now we need to understand the scene. How spread out is our data? And this brings us to measures of variability. See, just knowing the average isn't enough. Imagine two basketball players who both average 20 points per game. One of them scores exactly 20 points every single time. The other one scores 40 points one game and 0 the next. Same average, but a completely different story, right? We need to know if our data is consistent and all clustered together, or if it's kind of wild and all over the place. Let's look at this great example. We've got two workers here, Rachel and John, and their output over 5 days. Just by glancing at these numbers, you can probably get a feel for their work styles. Rachel seems incredibly consistent, while John's output is, it's a bit of an adventure, let's say. Now, to put a number on this spread, we can use a really simple tool called the range. It's just the difference between the highest value and the lowest value. It's the quickest way to get a sense of how variable things are. Okay, now check this out. Rachel's range is just 2. Her best day and her worst day are barely different. She is the definition of consistent. But John's range is a massive 24. This one number tells us his performance is super variable. So you see, by measuring the spread, we get this whole new layer of understanding that the average alone could never, ever give us. So Our detective work is almost done. We've found the center of our data, and we've measured its spread. Now for the final and most critical step, presenting our case in a way that everyone can understand. This is really where the magic happens. A great chart or a graph can take all those numbers, all those means and ranges, and turn them into a simple, intuitive picture. It's all about storytelling. It's about making your findings leap right off the page. And you have a whole gallery of options. You could use a bar chart to, say, compare sales between 3 different stores, or maybe a line graph to show how a stock price has changed over a year. Each chart type is a different way to tell your story, from histograms that show you the shape of your data to box plots that give you a quick summary and can even point out those pesky outliers for you. But here's the thing, choosing the right chart is key. It's just like how a writer chooses their words carefully. A data detective has to choose their visuals with precision. The right chart tells a clear, compelling story, but the wrong one can confuse people or even worse, deceive them. And that brings us to our final and maybe our most important piece of advice. These tools are incredibly powerful for finding and telling stories with data, but that power comes with a serious responsibility. Okay, here's a classic trap that even seasoned researchers can fall into. Sometimes, if you have a big enough data set, you can find a difference that is statistically significant, but in the real world, it's completely meaningless. Like a new drug might lower blood pressure by a statistically significant amount, but if that amount is so tiny it has no real effect on a person's health, is it practically important? Not really. So, I'll leave you with this question. Now that you're armed with your new detective's toolkit, the next time you see a headline with a shocking statistic or a chart that seems a little too good to be true, will you stop and ask yourself, what story is this data really telling?